Today I'm going to go over how to ram cored black powder rockets. The first thing we're going to have to look at is the tooling involved. Here I have two models of handmade tooling that I have made myself. Commercially made tooling is available but is rather expensive. Right here is the simplest type of tooling you can make at home. This is a 1/4 inch aluminum rod inserted into wooden blocks. The end of this rod is tapered so that the rocket will slide off more easily after ramming. Now, despite the taper that has been given to the spindle on this set of tooling, it is still going to be very difficult to remove the rocket from it after ramming. That is why I have also made this set of tooling. Now, the spindle on this tooling is made of brass. This was ground down from a threaded brass rod just like this. To grind this rod down, I chucked it into the bit of a drill and used both sandpaper and a bench grinder to get it into this nice tapered edge. Now you can see I've left a good portion of the threaded section of this rod on this spindle. This is going to allow me to more easily remove the rocket after ramming. Now once the rocket has been rammed on this tooling, it's going to look something like this. This top section of wood is then going to come off with the spindle, which will still be jammed into the rocket. Now all that needs to be done to remove the spindle from this rocket is to put a wrench on both of those nuts and twist them in opposite directions. Doing so will extract the spindle through the block of wood and therefore out of the rocket. You will see a better demonstration of how this tooling works later in the video. Now the other very important part of rocket tooling are the rammers. These rammers are made out of 3/4 inch dowels and have been cored out with a drill press to fit over our spindle. The longest of these rammers has a slightly tapered end, which allows a cone to be formed on the inside of the rocket nozzle. The second rammer is still core drilled, but it is not so long. This is because as we fill up the tube with composition, it's going to get more difficult to ram as the top of the rammer gets higher into the air. This shorter rammer allows greater stability. Now this short rammer is going to be used until we reach the end of our spindle, at which point we can switch over to this very short rammer which has no hole in the center. Alright, now here you can see what we're going to be looking for on the inside of our rocket. Here I have marked off that we want the nozzle to be at 3/4 inch height. I have this marked on our first rammer between these two spaces. When I have this inserted into the tube, I'm going to know that I have reached my proper nozzle length when I get to this second line. Now when I reach the third mark in my rammer, I know it is now time when I can switch over to my shorter ramrod. Putting these marks into the rammers is going to make it much easier to ram your rockets consistently. Now I have made this tooling to suit motors that are 3¼ inches in diameter and 4¼ inches in length. The spindle is going to go into the rocket a total of 3 inches. Out of that 3 inches, 3/4 inch is going to be taken up by our nozzle. Right here above the spindle is a 1/4 inch of composition that is going to be burned away during the thrust stage of the rocket. This 3/4 inches is then purely delay, as the composition will not have enough surface area to produce reasonable thrust. It will instead create the timing between when the rocket reaches its apex and the header bursts. Now to start ramming this rocket, what I'm going to do is place this tube over the spindle. I will now take a small amount of bentonite clay, which is found in the cheapest forms of kitty litter, and put it into our first increment in our rocket. This clay is going to form our nozzle. I'll now remove the funnel and put in our longest rammer, which has the tapered end. Now in a similar way to how I rammed spolettes in a previous video, I'm going to take a mallet and ram our dowel in. Now I'm going to continue to ram small increments of clay in until I reach the second line on my rammer. This is going to indicate that I have a full 3/4 inch of nozzle in the rocket. I have reached the second line in my rammer, which means that the nozzle is now thick enough. It is now time to start ramming composition. This composition here is 60-30-10 potassium nitrate, charcoal, and sulfur. This is the standard black powder ratio for core burning rockets. I will now once again, in small increments, add this to my rocket. At this point, I have rammed my first increment of composition, which means we are somewhere above the nozzle shown here and still below the spindle. We are working on filling this area right now. I've now reached the third line on my rammer, which means there's enough composition in this engine to switch over to my shorter spindle. This is going to make it much easier to ram. Now on this rammer, you can see right here, I've also marked a line. This line is to indicate when I am above the spindle. You can see here that the line is now above the end of the tube, which means I can switch over to my very shortest rammer, which has no hole in the center because it is now going to be ramming composition up here. Here is my shortest rammer, which I will now start using. Now once a 1/4 inch of fuel has been rammed over the spindle, you are now no longer ramming useful composition. The rest is going to be delay. So at this point, rather than ramming more composition, you could decide to ram a bulkhead. That would finish this rocket. Rather than doing that, I am going to continue to ram composition, which is going to form a delay for my header. The rocket has now been rammed with composition within a 1/4 inch of the top, which matches the diagram I have made on the front. Now to add a header to this shell, all that needs to be done is to glue the header directly to the top of the case. Now, as I described in my previous video, removing the rocket from this tooling is a simple task. All that needs to be done is for the top portion of this wood block to be removed. You can see there are 2 pins on these lower blocks which allow this top portion to be aligned every time in the exact same way. I also have a hole in there which the bottom part of our spindle fits into. Now on the bottom part of the spindle are 2 bolts. By twisting these in opposite directions, I can now extract the rocket. So here's our extracted rocket. All that needs to be done now is to put a stick on it and it'll fly. If desired, you can now also put a header on it just by gluing a shell to the top. The burning grain as it reaches the end will ignite your fuse.